Thermochemistry is the study of energy changes. Thermal energy is a result of the motion of particles. A chemical system is a set of reactants and products in varying temperature ranges. I'm sick and tired of reading those damn chemistry articles.
Q is equal to mc delta T, where Q is the amount of heat transferred. C is a specific heat capacity, which is the quantity of heat to raise the temperature of a unit mass of substance 1 degree Celsius or Kelvin. M is the mass, and delta T represents the change in temperature.
Dina is so damn cool. She once taught me that an exothermic system's energy is released, while an endothermic system absorbs heat from its surroundings. In a closed system, energy can't move in or out, so energy loss is the least. Open systems freely let energy move. It has so much to improve.
Delta H systems is equal to the plus minus of the absolute value of Q surroundings, where delta H represents the difference in enthalpies of reactants and products during a change. Enthalpy changes for exothermic reactions are negative, where the opposite is true for endothermic reactions.
Chemical changes, a change of chemical bonds between atoms which create new substances. Physical change changes the form of a substance, whether it's a solid, liquid, or gas. Nuclear change is a change of the protons or neutrons in an atom, creating new atoms. That's just the way it is. Things will never be the same. Aw yeah. There are several different types of molar enthalpies of reaction. Solution, combustion, vaporization, freezing, neutralization, and formation. The molar enthalpy is equivalent to enthalpy. Bonnie is the G from the 613.
There are several assumptions with the calorimetry of physical changes. Heat will not be transferred outside the calorimeter. Heat energy absorbed or released by the calorimeter is minimal. An aqueous solution is assumed to have a specific heat capacity of 4.18 kilojoules over kilogram times degree Celsius. Don't you forget that significant digit decimal.
Dina once told me that there are 4 different ways of representing enthalpy changes. Method 1. Thermal-chemical equations with energy terms. The amount of energy is in the equation is always positive. If on the left side, it is endothermic. If on the right, it is exothermic. Method 2. Thermal-chemical equation with delta H values is the amount of enthalpy energy listed on the outside of the equation. It can be positive endothermic or negative exothermic. Method 3. Molar enthalpy of reaction is the same as method 2, except the chemical involved in the reaction must be 1 mole. The reaction must take place at SATP and the energy is expressed in positive or negative kilojoules per mole. Method 4 is the potential energy diagrams.
Hess's law is something that's fun. It doesn't matter how you get there, you'll always end up in the same place when the reaction is done. Delta H is directly related to the chemical equation. When the coefficients of a chemical equation are altered, delta H is affected too. The standard enthalpies of formation is a key concept. The product of a reaction has to be a single mole, while the reactant states must be in standard states, otherwise you will be in the hole. You gotta remember that the standard enthalpy of formation of elements is 0 when in its standard state. This is gangster music, do or die, don't hate.